Hi guys, we're going to have a quick look at problem 419 in chapter 4.4. It looks like this. Okay. It says here, the 70 Newton force, I hope you can read that. By the way, this is 414 in the 13th edition, if I'm not mistaken. 414. We're looking at 419 here. What we have is this kind of a rod or pipe, this kind of T shape, and we've got this 70 Newton force being applied over here, and it says the 70 Newton force acts on the end of the pipe at B. Determine the angles, perhaps I can bring this a bit closer. Determine the angles theta, okay, theta must be between 0 and 180 degrees of the force that will produce, take a look here, maximum and minimum moments about point A. Determine the angles theta of the force that will produce maximum and minimum moments about point A. Okay, so if we have a quick drawing over here, okay, there's my point A, there's my point B, and I have this force here acting there, F, equal to 70 Newton, which is not very important to me right now. And we've got this angle here, theta, and obviously if the force is being applied there, our angle is 0, and if it's being applied like that, it's 180. Okay, that angle, the angle increases like that. Okay, so the question now is, this force can be applied at between theta equals 0 and theta equals 180. At what angle, theta, would this force give me a maximum moment about point A? Okay? So guys, what kind of concept should we take out of this? And then also the next one is, at what angle would this force give me a minimum moment? So what I want to just ask you is, if you had a straightforward beam like this, right? Just a straightforward beam. Imagine that's just a straightforward cantilever beam, and I said there's a force there, F. There's my point of rotation, let's call it O. And I said to you, at what angle should F be applied, okay, so that it gives me a maximum moment about point O? I'm pretty sure that most of you would say, well, it needs to be perpendicular to the beam, right? It needs to be perpendicular, so that force needs to be applied like that, perpendicular to the beam. Then my moment, which is force times distance, the force would stay exactly the same, but my d would become a maximum. First of all, what is my moment arm for this force? Well, if I extend the line of action and I draw a line from that point perpendicular to that line, that would be my original d. Okay? But if I want to maximize the moment using this force, I need to maximize this distance d. So I change the angle to perpendicular, and then that becomes my new d. As you can see, that d is larger than that d, and that is my maximum. So what do we need to learn from this? If we have a point of application and a point of rotation, what we need to do is draw a straight line between those 2 points. Okay? So let me give you another example. If I have some funny shaped object which doesn't exist, okay, maybe this does exist, I don't know. Some funny beam, okay? It's not a snake, it's some funny beam. And I say to you, I'm applying a force there, okay? And there's my point of rotation, and I want you to tell me at what angle must my F be, what orientation must my force be, so that it gives me the maximum moment about point O. Guys, do not please, 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 do not look at the shape of the body. Don't look at the shape. All you need to do is draw a straight line from point O, point of rotation, to the point of application. Look at that line. Then ask yourself, how does this F orientate towards that line? Because if that force, in order for that force to give me a maximum moment, it needs to be perpendicular to that line. Okay? It needs to be perpendicular to that line from the point of rotation to the point of application. Similarly with this beam, the reason why this answer might have been simpler is because the body and this line were identical. Whereas here you've got some funny shaped body. So my serious advice to you is when you're trying to see what's happening, okay, with moments, draw a straight line from the point of rotation to the point of application. Then in order to determine the maximum moment, the force, the applied force needs to be perpendicular to that line. Because then our M equals FD, that would be our moment arm, okay, based on this perpendicular force to this line. Okay. What about a minimum? Well, for a maximum, the force needs to be perpendicular to this line. Okay? For a minimum, we know that the force needs to be directed along this line so that my D becomes 0. Okay? So let's come back to this problem here. Perhaps many of you would say that the maximum moment would be if I orientated the force in this direction. Then that would be my moment arm. Okay? Others would say, no, it needs to be orientated like that. So that would become my moment arm. But you're wrong, I'm afraid. Draw a line from the point of rotation to the point of application. That is the line that you need to look at when you're saying perpendicular or parallel. So this force needs to be perpendicular to that line there. Okay? So that's the initial concept there. For maximum moment, my F needs to be perpendicular to this line A, to the line AB. Okay? So what are these dimensions? I've got 0.9 here. That length is 0.9. That length is 0.7 meters. Okay? So what is this angle if I want to call it phi? Phi equals tan to the minus 1, 0.9 over 0.7, which gives me, I think it's 52,12 degrees. This angle here, okay, is 52,12 degrees. So if I have 52 there, 52,12, I've got 90 there, what would my theta be? Theta is then equal to 180 minus 52,12 minus 90 equals, so 180 minus 52,12 minus 90 gives me 37,9 degrees. So guys, for this force F to give me a maximum moment about point A, I need to draw a line from the point of rotation to point B. This force needs to be perpendicular to that line. I then calculate all the other angles involved and I determine theta. So this theta is 37.9, which means that this force would give me a maximum moment. What about a minimum moment? The minimum moment means that this force has to act along the line of action of this force, so that my moment arm would be 0. But we can't let it act like that, in that direction, because we only allowed forces like in that range. Okay? We're only allowed forces in that range like that. So obviously, for minimum, it needs to come down like that. Right? So we are looking at this angle here. We're looking at that angle. So what would that angle be? It would simply be, so angle for, not the maximum angle, but the angle for moment maximum is 37, and the angle for moment minimum equals 180 minus 52,12. Sorry that this page is so messy. Makes it more exciting. And this answer then becomes 180 minus 52,12. Basically 127,9 degrees. So this angle here, 127,9 degrees, would mean that this force is acting along this line of action away from A towards B. That would give me a minimum moment. Okay. So I'm sorry it's so messy, but I hope you've picked up some important concepts. Let me know if you don't understand. If you don't understand, I'm not sure what we can do about it, because we've explained it very well here. Okay, guys? Good luck. Cheers.